This is what we get. We get nice graphics in magazines and newspapers and on websites showing us, you know, where it's going to go and all the gold foil again. On the way to Pluto. And then it sends shots back like that, so it must be in space. But as soon as this came out, again, you know, a lot of people went, this is a joke, isn't it? Seriously, there you go, Pluto. But again, unless you kind of question it, you just accept it. Put it into Photoshop, adjust the levels, you can quite clearly see this is not the New Horizons probe, you know, just passing by and taking a photograph. It's been layered in to creation. And this is the other half of it. So you've got the graphics and the CGI. You go, hang on a minute, well, we see rockets go up, don't we? Well, we see them go up, but very quickly they start levelling off and coming down again. And what we never ever see, and I did a huge search for it, we never see an unedited shot. I mean, there was 135 space shuttle missions, so somebody could have put a camera out the front window and, you know, let it roll. Let's see what it looks like. It's not going to take long. It's going to take 15, 20 minutes. Never see it. In fact, there is a cockpit, there is one cockpit video, and it's pointing backwards towards the crew. Who wants to see that? I don't care, show space. I want to see space. They all go on the side. I'll show you a few minutes of rocket launches now. From all different countries, all over the world. And we'll see it, you know, shoot up, and we know amateur scientists can get rockets to go. You think, oh, those crazy Koreans, they'll believe anything. There we go, it's still going up. Oh, it's coming down again. Not going into space, that, is it? Yeah, it's definitely coming down now. That's what we get, graphics, CGI, command centre. Wonderful. Can't believe it, the generals. We've finally done it. We finally put a rocket 100 metres up in the air and come down here. There you go. This is the Orion. This is NASA's Orion. Delta 4. The Americans wouldn't do that. The Americans are, you know, they're not liars, are they? Surely they're not lying to us. There you go. Any minute now. Up and away. No, it's coming back down. It's definitely coming down. It's coming down. I want to see a rocket go right the way into space. And I know, obviously, if you've got a camera on the ground, you only see it go so far. Cameras are obviously run out of light energy, but stick a camera on the thing. They've got all this technology. Show us. That's what they've got to show us. They have to cut to computer-generated images. Why? Yeah, we've definitely done it then. It's impressions. It's impressions on the mind. Because after that, they're going to show us graphics and say we're up there. Again, levelling off, and it's a downward trajectory. There you go, the booster rockets. Oh, it's definitely come back down again. Okay, we're off to the moon. We're going to the moon now. Here we go. Up, up, up. Up. So infinity and beyond. So 1 minute 40, not got very far, has it? I know, I know the apologists or the flat earth deniers say, well, it's going to go so, and then it's going to catch the orbit of the Earth. It's not gone very far. It's only gone up a few miles. It's not gone high as a plane. Some of these. I mean, you know, and then we're on the moon. What? Apollo 16, the same. Like I say, the best thing to do is have a look for yourself. There are, you know, plenty of rocket launches around. You can test all this for yourself. Don't believe what I say. You know what I mean? I might have just picked the ones that seem to go down or something, but you'll find that they all do the same, and there are no unedited videos that show us going all the way into space. First shuttle launch. Going on. Here we go. Oh, it's on the side then. It's very bad. Levelling off. There go the rockets. So that's its maximum velocity. We can still see it, so it can't be that far, can it? Here's a picture of the smoke. It looks right on my screen. Any text? Hello? Is there a video tech around? No? Oh, there we go. Thank you. Oh, no. It's NASA interfering. We're back on now? Wonderful. Okay. That's enough of that. Yep. Okay. So we'll come back to our favourite genre of movies. I was a huge Star Wars fan. I love them all. Star Wars, Star Trek, you name it. The point is that these are there to fill in the gaps in our mind, because we've never seen from NASA or any other space agency around the world what it actually looks like to go into space, what it feels like to go into space. But we have a whole, all our generation were brought up with it. Right the way through, and this is how they fill in the gaps. Again, it's a subtle programming trick, I suppose. They'll show us the rockets going up, and they'll tell us, yeah, this is doing this, and in the meantime, they're not trying to say that the sci-fi is real, but in our minds, we kind of put the two together, so it's an impression again. And you've got to ask yourself as well, hang on a minute, if NASA don't go into space, if they really do fake it, they launch a rocket up, it goes into what you're seeing, here's some graphics, or here's what the moon set, or what have you. Why did they have to fake it? They get $19 billion a year at the moment. So, why not spend that money and actually go into space? Is it because they can't? I'm going to come back down to earth now. We need to know what we can see for ourselves, what can we observe, what can we establish that is definitely true. Because we look up and we can see the stars, and the dark rift in the sky and all the rest of it. So what do we actually know for sure? Well, if we're on a globe, there has to be curvature. We should be able to, at some height, at some distance, we should be able to experience curvature. Things should drop out of view. Yeah. I can't hear you from back there.
I said you can see the curvature of the earth from Land's End.
Right, okay.
Where's that?
Okay, two things to notice about this particular photograph which you might not have straight away. First of all, there's a city there in the distance, and also, just note for later, the reflection of the sun on the water. One of the big arguments for a ball Earth is that ships disappear over the horizon. Hull first. Everything disappears, bottom first, but on the horizon. Ships are, for a 6 foot tall person, the horizon is only 3 miles away. Okay, if you're 7 foot, you're standing up, obviously it's going to be a little bit further, 4, 5, 6 miles, however far you want to say. These ships are disappearing. It was one of Aristotle's biggest proofs. And people still say it nowadays. But there's a big problem with it. Because if we're on a ball and there's a curve that way, and the ships are disappearing that way, then we should see a curve that way as well. And not just across the z-axis, but across the x-axis as well. If you're telling me that ships are disappearing on the horizon, or we can't see the bottoms of buildings and mountains just because of the curve of the Earth, then I want to see the curve of the Earth that way as well. Because it should be even, shouldn't it? We should see it both ways. If you're going that way and it's disappearing, then you should be able to see curve that way. And obviously you can't, because every single thing we see is flat. Every single horizon we see is flat. Just notice the sun and the reflection of the sun on the water there. I'm going to miss that video out. Okay. I maintain that we see things disappear in the distance because of the limits of our eyesight, because of the way perception and light refracts over water, and so on and so forth. It's not useful for us to be able to see 1,000 miles. Probably be quite dangerous, to be honest. But the point is that I don't think these these turbines are disappearing, over the curve. I think they're all, exactly level, but because of the way light works. I've got the video. Show you this very quickly. Now watch this. As the temperature changes, the conditions change. Watch it appear and disappear. It'll mirage. It'll do all kinds of different things to our perception of it. That's obviously a speeded up time lapse. But is it disappearing behind a curve? It's not, is it? It's the way the light, is obviously hitting the lens. It can make it appear massively different. From almost nothing, from a tiny thin wedge to and obviously we've seen there's full buildings on there. So the way our eyes work has got a lot to do with how things disappear in the distance, and it makes sense for us, like I say, to be very aware of the things close to us, and things 200 miles away are not really that important. In the flat Earth community, we use it's supposed to be 3,959 miles radius, this Earth. So, as a shorthand, we do 8 inches per mile squared of dip. How much should things dip around? But the problem with that is, it's only taking it from this point here, as if we're on, 0 feet above sea level. So all we're measuring there, it's a good, rule of thumb. All we're measuring there is the distance from there to there, and the height things have to be able to see over the alleged curve. What we actually want to measure is this, from here. So you've got a height, and then the horizon, and then over the horizon how tall buildings, ships, lighthouses, etc. should be. It's a double Pythagorean equation. And this is the one that the debunkers use. Yeah, because we say, we can see, I'm going to show you things 30, 50, 60, 100 miles in the distance. And they say, we should be able to see them even with a curve and light refracting and everything else. So I'm going to use theirs and still show you that things don't disappear behind the curve like they should. Very famous White Cliffs of Dover, we're 22 miles away. You can see we're on the beach here. So we say we're 10 feet above sea level. 220 feet of the 350 feet of these cliffs should be obscured, and we can see them. Obviously, you can't see them all the time. You can only see them on good atmospheric days. So sometimes they can be seen, sometimes they can't. It's not because they disappeared behind the curve of the Earth. Toronto, from Niagara-on-the-Lake. Again, we can see virtually the whole skyline. It's a great day, great clear day here. We can see virtually the whole skyline. From Grimsby Beach, 34 miles away. Again, you can see it's on the water, and we can see the base, the whole city. From the other way around, we can see Niagara Falls from Toronto. Niagara Falls, the highest fall is 188 feet above sea level. Again, on the curve calculator, the Earth calculator, there should be 551 feet should be hidden behind the curve, and we can quite clearly see a lot of the falls there. Going on, this is one of the most famous shots. When it comes to flat Earth theory or flat Earth v globe Earth debate, Chicago from 54 miles away, and again we shouldn't really be able to see it. They say that yes, we should, and that's why the bottom of the buildings are missed. The bottom of the buildings have disappeared behind the curve of the Earth. But I've just showed you the lensing video, the atmospheric lensing video, and show you exactly why we can't see the whole city. I mean, we know that we can't see huge distances. Huge distances. On the calculator, it says that basically they say there's a bulge of 486 feet in between us and Chicago here. So there's a bulge, which is the curve of the Earth, and that's why we can't see the bottom. But I have a great big problem with it, and this is going to apply to every single thing when we're talking about distances and when we can see, whether we can see, over the curve of the Earth. If there's a curve of the Earth, and it's great to go on debunking sites and people that disagree with you because you can. Obviously get ideas for how they are wrong. Excuse me. So here's us. This is Joshua Nowicki took the picture from Grandmere State Park, and this is Chicago, and they reckon there's a 486 feet bulge in between here. Well, that means that you should be able to stand here, or here, and look up the lake, and see a big 486 feet bulge of water. Yeah, and that's true of all of them. That's true of whatever we look at. They say, well, we can't see it because there's a bulge of water, but obviously if you go round, then you should be able to see the bulge of water. If there is no bulge of water anywhere, this is what we see every time you look out, a flat horizon. If I saw a bulge, you'd go, oh yeah, okay, it's curving. But it's not. Never is. All horizons are flat everywhere. There's no bulge water. If you've ever been to a lake, it's flat. It goes on flat. You can see the Isle of Man from the Fylde coast, 61 miles away. Again, you ever seen the Irish Sea with a big bulge in it? The Isle of Capri from 102 miles away. I mean, I put all the you know, the viewer's height and everything so you can calculate for yourself. I'm not going to get right into it because the bottom line is we can see these islands from a long way away, and you're telling me there's supposed to be a bulge of water in between, or at least this horizon is completely flat. Barcelona, 115 miles away, we can see Magaluf, or no, it's not Magaluf, Mallorca, all the peaks of Mallorca. These should be hidden. This one had a lot of debate on the internet. If we say the photographer said he was at 2,717 feet above sea level. Well, from 149 miles away, which is where we are, this is Reunion Island from the ocean, you can see 4,836 feet of this should be hidden behind the curve of the earth. But Simon Def there is only 4,139 feet. So the horizon line should be here somewhere, if it was behind the curve. It's not. We can see the island. Show you this. Again, proving that it's not because of the curve of the earth that we can't see very far in the distance. You see the sun setting there, nice flat horizon. What's going to happen very shortly is we're going to see this peak come into view. It's not coming to view because, you know, you've gone higher or anything. It's coming because of obviously the way the light's working. I'll show you. As it sets, you see the peak. It's 185 miles away. We're looking across from the south of France over to the Pyrenees here. And again, comes into view. If the sun wasn't there, obviously a few days of the year when the sun sets at that position, you can see it. But if it wasn't there, you wouldn't be able to see anything. Not because of the curve of the earth, it's because of the way light and our eyes work. And here's the long distance photography world record. It's basically 273 miles. I'll show you the photo now. I just want you to take note of this hidden target height. This is what should be, it should be hidden behind the horizon. Something needs to be 4,900 metres high. It's 5 kilometres, isn't it? Virtually 5 kilometres high. 4,900 metres high if we're to be able to see it. But we can see here, the Bar des Écrins is 4,100 metres high, and this is it here. Yeah, it's quite a chunk of it. It's not just a little tip, it's quite a chunk of it we can see. The horizon line should be 800 metres above that. And again, this guy was just, taking the world record long distance photography. He's not trying to prove that the Earth's flat or anything. In fact, if you go into the discussions and say, yeah, but refraction and all the rest of it, which means we can see behind a curve, we can see behind corners all of a sudden. 273 miles. It's a long way. There's a lake in Russia which is 395 miles long. It freezes over every winter, months of the year. It should be 19.7 miles of hump or curve. Again, ice doesn't curve and hump and bump, it's flat. It does, we all know ice freezes. If it freezes flat, just the same as water. When it's wet, when it's liquid, it's flat. And a lot of people will maintain, I've seen the curve from an airplane. Airplanes fly at 37,000 feet, around 7 miles up. So if you've seen the curve from 7 miles up, how did this V2 rocket in 1946 not see the curve from 65 miles up? Not there. Purple line there showing where the curve should be. It's just a flat horizon. You might ask, well, Why don't you send up a balloon? Let's have a look for ourselves. Forget NASA, forget the telescreen, forget all these liars in government. Let's do it for ourselves. People all over the world have. You'll never guess what I'm going to show you now. Well, anywhere between 85 and 120,000 feet these are going to be. Look at the horizons. Our planet is beautiful. It's not really a planet, it's terra firma. But the Earth is beautiful, it's a great big plane. It hasn't changed, we still live in the same place, but from above you can see there's no curve. Now you might go, oh, hang on a minute, I can just make out a curve. I'll show the shots in a minute where there's a real curve. Big, beautiful place, but it's just a big plain. Yeah? It's a big, I won't say flat because it's got mountains and rivers and valleys and all the rest of it. So I like calling it a fixed plain. Again, there's no movement. Okay, so I think this is still shots, probably why there's no movement. But again, when you see the videos of the balloons themselves, you'll see that not only is the horizon flat all the way up there, you know, we're talking 20 miles up for these, you know, it doesn't move. There's no, again, visible movement of the Earth underneath. I think that's the world record for an amateur balloon. You can see the clouds, very, very small in the distance. So you might go, well, I could kind of see a curve there, kind of make myself see a curve. But not like that, which is what the shots show us all the time. It's great big curve. There's no, obviously, landmass here or anything so we can make things out. Again, how high up is it? How up is the shot? You've just seen from 112,000 feet, 22 miles, we've seen the clouds looking very, very small. This looks lower to me, but it's got a great big curve on the horizon. The other question is, who took this shot? Is something following the ISS at perfect orbit to it at 17,500 miles an hour so it can take a shot and it's all perfect and you know, no blurriness. This is when we experience a curve of the Earth, when they use barrel lens distortion to make the Earth seem curved. Remember Felix Baumgarten's jump, famous jump in 2012? You know, great big media event. We can see the curve there, but if that's the curve of the Earth, then it's not very big. Doesn't make sense. Here's a shot from the video, here's a still from the video, by the way. It's just as he's about to jump out. So they don't get everything right, they don't fake everything brilliantly. But and it's only for a split second. Again, go at the video yourself, have a look for yourself. It's 127,000 feet, and it's a complete. But how we get from that to this curve, I have no idea. I do know it's barrel lens distortion, and they're trying to deceive everybody. 33 kilometres up, flat horizon. The other great thing about this particular weather balloon is this here. Now these are clouds, this is not the sea. These are clouds here. You can see there's a sunspot. There's a reflection of the sun, but a particular heat spot just concentrated there on the clouds. When you see the video itself, which I haven't got today, you'll see the sun. You see it bounce up and down the sun and the sunspot and the hot spot underneath it. Which again, if the sun's 93 million miles away and huge and it's sending all its rays parallel into the Earth, what's it doing with a localised hotspot? Doesn't make sense. This is what we see. We see it on water as well. Just to note before, what you see is what looks like a local sun emitting a local reflection. Because again, I know the idea is, you know, the light rays come in and they're spread out, obviously they're spread out more north as they are, you know, towards the equator. But surely we shouldn't get such localised, I mean, this is a few metres. Why isn't the whole sea lit up? It should be. If we're getting all the rays, you know. Here we are, you know, if you're in Britain, on the south coast or what have you, and you look, you'd see that reflection. That's the reflection we see all over the world. It should also be different all over the world as well. It should be smaller at the equator and obviously larger as we go further north. Again, we see a local sun with a localised reflection. Ask yourself this question as you watch these very quick time lapses. Is the Earth moving or the Sun? Because people say, if the Sun's moving, it should get a lot smaller on the horizon. It should be a lot smaller on the horizon, it should grow. But if you've got an unobstructed view, that's exactly what you see. And now don't get me wrong, I've seen the Sun huge on the horizon as well. Is the Earth moving or the Sun? You know, is the Earth rotating towards and rotating away from the Sun? Or is the Earth completely still and it's the Sun moving about over, bringing light and heat every day? From an airplane, 7 miles up, the sun's disappearing into the distance. You say, well, okay, yeah, NASA are liars, yeah, they can fool us with a telescope, you can't fool science, can you? There's a scientific proofs, isn't there? One of the most famous ones is Eratosthenes, who famously proved the Earth was round. No, he didn't. He was measuring the circumference of the Earth. He'd already assumed that the Earth was a ball in the first place. And the thing is, you know, it's the difference in the length of the shadows at two different points on Earth, 700 miles apart. He chose to accept this explanation. Sunlight's coming in parallel, hence cause those different shadows. The other explanation is just as valid. So small sun create exactly the same difference in shadows. There's no proof at all. In fact, you'll find most of these proofs, most of the scientific proofs, all assume previously that the Earth is a ball or it is spinning, etc., etc. So they have to start with that assumption and then they can prove it. But without starting with that assumption, you can't. The distance. Not only is the distance to the sun been changed, you know, again, we go to school and they say the sun's 93 million miles away, everybody knows that figure, but that has changed ridiculously since Copernicus first came up with his convoluted theory. Not only that, they also used to think that the sun was still, that the sun was fixed in the centre and, you know, everything's revolving around it, but Herschel then said, no, the sun's moving as well. And then we know nowadays we've got that Nassim Haramein graphic with the sun, I've got it somewhere, and the sun leading the solar system away through the galaxy. So it's not fixed, it's not like the science is settled or anything, it changes all the time. And here's an important question, so I'm going to take this down and I'm getting on it. That's enough programming. Shooting stars. Again, sorry, just on the point I needed. Right, here you are on Earth. Where we are, here we are in Britain. And we see shooting stars, we see them come down. I mean, they can come from the horizon, and possibly cross to the other horizon, right? But most of them kind of shoot across down. What they never do is shoot up from the horizon straight up. But if you're on a ball rotating, why don't they ever come up on the horizon and just go off into the... No, they all come down. Every shooting star, every meteorite and asteroid, they all come down. Here's something you can do for yourself. I think the moon's probably about the right phase now as well, so you could do it tonight or the next few days. Whenever there's a sliver of a moon, up to about a half, it doesn't quite face the sun. And this is a photograph. Here's the sun in the sky. Here's the moon. Now you know in your mind, move those two bodies around so that the moon reflects properly from the sun. You play pool, you've got to line up shots, or snooker, you've got to line up shots and they've got to be accurate. You can quite clearly see here that this moon is pointing to a sun that way. You'd have to move them, you'd have to bring the sun right down and move the moon up to get that kind of reflection. But you can see this for yourself. Go notice the moon over the next few days and weeks for yourself and check the angle and check it's correct. Sometimes it's quite close, but sometimes it's like 10 or 20 degrees wrong. I mean, this is, I don't know, what would you say, almost 40 degrees, 30 or 40 degrees wrong there. Another big proof that's always ruled out is the Foucault pendulum. This is a great big, they have them in museums and universities around the world. Great big pendulum, hung from the ceiling, and it swings back and forth, and slowly over the day, it will swing round throughout the plane over 24 hours because the Earth's apparently rotating. But there's two problems with that. Number one, all pendulums in the world would do the same thing. Everything swinging freely would rotate because of the rotation of the Earth. The other problem with it, again, when you go investigate, they actually admit themselves, without kind of admitting it, that it's not just a free-flowing pendulum that's moving with the rotating Earth. The one at Monash University, I'll just read this summary very quickly. It says, a Foucault pendulum is described which has a novel drive, so it's driven, and a new device preventing it from ellipsing. So they normally ellipse. Foucault pendulum is not a proof at all, and by their own admission, this is, NASA astrophysics data system. New Foucault pendulum, but we have to drive it and damp it, rollers and Charon rings, electronic supports, and everything else. Not only can we not see curvature, there is no motion. We don't feel motion. Now, whether you believe or not the Earth is moving, you must admit that your senses are, the semicircular canals in our inner ear, our senses tell us that we're fixed, that we're stationary. I know it's supposed to be an optical illusion, but if there is no movement of the Earth, then the whole model is gone. The whole model is wrong. Now you say, well, we can't feel it because it's got a constant velocity and a constant direction. Well, number one, it's not, because it's going round in an ellipse around the sun, apparently. So it changes direction all the time. The other thing is, it's not a smooth ball. There's an 18-kilometre variation between the highest mountains and the deepest valleys. Now that should cause some kind of change of velocity, even if it's slight. You should feel it. Make the analogy that if you're on a moving car or a moving train or on a plane, you don't feel the motion until it slows down, speeds up, changes direction, and that's fair enough. Although the Earth is not enclosed, it's not a great analogy. But again, it's not a smooth ball. So if we're spinning around, at some point in the air, the resistance should hit these mountains and should slow it down and whack it up. But there's bigger than that. There's quadrillions of tons of water all over this supposed globe. Oceans and oceans. So as it's turning, if you've got a tray of water, all you have to do is move it a little bit, and what does the water do? Inertia's off, quakes away, doesn't it? And this is, the Earth's supposed to be travelling out the equator at 1,038 miles an hour, rotating at 1,038 miles an hour on its axis. How is that not sloshing the water around? Like we know in real life, with our own experience, but we only observe. They say the moon causes the tides, but I don't know what gravity. Obviously it's a sixth. I suppose sixth. Gravity's supposed to be sixth of the, a sixth strength on the moon. But you're telling me from 240,000 miles away that affects the tides, but the spinning of the Earth doesn't. The other thing is the continental drift again. It's the other way around. This is what they show you. It was once Pangea. All the continents, all the land was at the equator, and over time, it's separated apart. This is what they teach us in science, teach us in school. But again, if that was the case, if we were rotating around, well, you need a globe to debunk the globe. And if it's rotating around, and this is where all the centrifugal force is, all the land masses should have drifted towards the equator by now, especially if it's been around for 4 billion years. Things weigh exactly the same at the equator as they do in Britain or the North Pole. And again, that shouldn't be the case. Weight should be different everywhere. Because these are experiencing 1,038 miles an hour rotation, these are experiencing none. We're about 700 miles up here, allegedly. Airplanes would have a great big problem flying, whichever direction. But if they're going from, say, north to south, and again, the rotation is increased. so it should have to take account for that. How do they ever land unless the runways are exactly east-west and they're coming in east-west? How do they ever land? Well, they say all the atmosphere is spinning along with the Earth. That's why we can't feel it. That's how, planes can still fly and everything else. But they want us to believe that the atmosphere is basically acts like one big solid directly attached to the Earth. That's the only way that you wouldn't feel it. But the atmosphere is gas, it's air. Yeah? They say because of friction, that's what gets the air going. And, okay, it's going to create a little bit of friction, but it's not going to you can't get a solid just by friction to get a gas to rotate along with it. Again, get a tennis ball, football, any kind of, throw it. The air doesn't stick to it, it cuts through the air. The exosphere is supposed to be 6,200 miles above the Earth. So it's another, the radius 3955, so it's about out here until you get officially into space according to NASA. So we've got all this air all rolling around with it. And not only that, the higher you go, the faster it must be spinning, obviously. Because if you're on the outside, it's got to cover the same distance. It's got to cover a greater distance in the same time. So it must be going faster. So not only are we supposed to believe that the friction, the friction's getting the air going at exactly the same speed at the surface, but that air is then getting the friction of the higher air to go even faster and even faster. Again, this is nonsense. When you actually break it down, this is nonsense. It doesn't work. It doesn't work, scientifically. There are no experiments that prove the motion of the Earth. In fact, quite the opposite. If you look up Michelson, Morley, Sagnac's turntables and Airy's failure, three of the most famous experiments in the 19th century, and they all basically prove that we're completely and utterly motionless. That's why they had to bring Einstein out in 1905. They call the theories of relativity, special and general relativity. Now, not only is the Earth orbiting on rotating on its axis, but it's also orbiting around the Sun. How does that not affect the atmosphere and the spin? And then the whole Sun's going through the galaxy at 500,000 miles an hour, yet we can't feel a single thing. That's not true, is it? It's magic. There are no experiments. When there's an earthquake, and we're lucky in Britain, we don't have very many, but when we do, it's like, there's some big ones in New Zealand recently. That's what the Earth would be like if it was moving. It'd be carnage. The other great big clue that we're not on a spinning ball is the way water acts, the way rivers act. Rivers flow downhill, north, south, east, west, they flow downhill. But again, the Nile's 4,000 miles long, and it flows that way, it flows north. Yeah. It's impossible. Every river in the world flows from, obviously, its source, generally up a mountain, out to the sea. Oh, gravity. Well, if gravity's working, then why does it flow at all? Why doesn't it stick it to the bed? It's not what we experience. All water finds flat. Get a tray of water and leave it be, flat. Swimming pool, nobody in it, nice clean pool, flat. Lake, the sea, the ocean, flat. Water always finds flat. The bottom of it will take the shape of the container, but the surface is flat. So at what point does water start curving into a ball? And you get tiny molecules, tiny raindrops of the ball, but as soon as you put a few of those raindrops together, it forms a puddle. But they want us to believe that, two-thirds of the Earth is water. That I do believe, for the moment. We've got this great big ocean here, but it's not flat. It does what water doesn't do, what we've seen. We observe water finding flat, but they want us to believe that water curves around the ball. The US Navy have probably have several, but they have a weapon, a laser-guided missile. And the tech that actually work on it, that actually fire it and use it, they say, they shine the laser at the target, and there's no other way for the missile to get there. As long as that laser's on the target, the missile will follow and hit that target. But they go for 50 miles. So how does it see through the curve? Does the missile punch through the water? Again, these wouldn't work. Neither would the... I can't remember the name of the gun, but it fires 100 miles. Again, how's that going to hit its target? So well, hang on a minute, what about the tech we've got? We've got a cell phone, we've got Sky TV, all this other stuff. How do they work if we haven't got satellites in space? Well, quite easily. With antennas, towers, ground-based towers. Some of it, is reflected off the atmosphere, some of it's tower to tower, some of it's cable. But this system's been around since World War II. And they always say that public tech's about 50 years behind what they've actually got. So again, they have this system, and you can see it's covering Britain, covering the coast of the eastern coast of the United States, much of Europe. World War II, 1940s, cell phones were released about 1990s, weren't they? So 50 years after the fact. How does my Sky dish work? How am I getting satellites? Getting it from tropospheric scattering. I'll read you this. One useful form of radio communications technology for applications where path lengths of around 800 kilometres, that's not the limit. You can go well over 1,000 kilometres if you wanted to. Are needed is known as tropospheric scattering, or thankfully shorter, troposcatter. It's a reliable form of radio communications that can be used regardless of the prevailing tropospheric conditions. That's why your TV picture doesn't wave, go fuzzy very much. Although reliable, when using troposcatter, the signal strengths are normally very low, so they require a very high power transmitter and a very finely tuned receiver. And this is what a great big receiver looks like. Shape ring the bell? It's kind of pointed out level, and it's got that kind of dish. That's tropospheric scattering. It costs millions and millions and millions to lay cable under the sea. So why do it if we can just send satellites up and it can bounce the signals around the Earth? Very, very expensive stuff, and this is, they're everywhere, connecting all the continents. All these great big antennas, Winter Hill, why do we still need that? Why are Google using drones? Now, satellites actually do exist, but they're not up there in space, unless you can find me a photo or a video of a real one. They do put satellites up there, and they've been doing it since 1960. And this is the Echo 2. And they can go for a long time. I think the record's 250 days. It can be launched from locations worldwide for science, can be ready for flight in 6 months, low-cost method, stable platform. They don't try and hide it, they've got a suborbital program. Why have NASA got a suborbital program if they've got an orbital program? Why? Let's go to space. Well, this I can believe completely. Sounding rockets and UGLBs launched from several different places all over the world. They don't try and hide it. This particular one here looks very much like the Kepler telescope to me. Not saying it is, I haven't got proof of it. But they're launching satellites mainly a lot from the Antarctica, but some from Sweden, various places. They all like satellites to me, and they go on great big long balloons. Have I got the? No, I haven't. Yeah, the record's 250 days, that one's up there, and they can keep launching them. Very recently, NASA came out with the fact that they found 7 exoplanets. This is how they find them with that Kepler telescope, which is, 20 miles above us. A star dims its light for a little bit. It twinkles, in other words. And this is how we measure. What planets are going around what distant stars. That's what they tell us. It's only been in service since 2011. It's found something like 4,000 exoplanets. But the Earth takes 1 year to go around the Sun. So if we're watching the Earth from the distance, we probably want a couple of years, 2-3 years, to make sure it's definitely a planet and not a speck of dust or something else. You know what I mean? If it's a planet, it's going to have a regular orbit. But they found all these planets very, very quickly. Oh, there we go. 4,696, and that's Jan 2015. So it's probably up in towards 10,000 now. I'll show you this video very quickly. Where are we up to? We're nearly finished. We're now time 10. Okay. I'm not going to show you the video because I want to get through a couple more things. This is stills from the video. We've now got cameras like the Nikon P900. And we can actually zoom in on the stars. Now they're distorted, we can't see exactly what's going on. There are, you know, all kinds of aberrations and what have you, but they don't look like a solid yellow disc. They're all different, they're all unique. A lot of them are multicoloured, they dance all over the place. And the other thing is, if we can see such detail, and it's not massive, but if we can see, you know, what form they are, then they can't be that far away either. They can't be trillions of light years away. Stellar parallax is a big fraud, and I'll show you why. Look at your thumb. That's about an inch. Yeah? The thumb's about an inch. What they're looking for is measurements of movement of a 15,000th of an inch over a 6-month period. Yeah? And point a telescope at a particular star, and supposedly one side of the sun and the other side of the sun, they're trying to triangulate a massive distance. Just look at the tiny, tiny differences. 1/15,000th of an inch. When angles are as small as this, we inclined to agree with Tycho. He said angles of parallax exist only in the minds of the observers. Now, most of distance astronomy, most of this idea of vast outer space comes from the idea of stellar parallax, which you can't see. Obviously, the constellations stay the same every year, year in, year out. Yeah, the skies don't actually change, but they're saying the slight movements, so they are slightly moving apart. Two things could be easily caused by an earthquake. We have earthquakes all over the world, all the time. Or refraction of light. I mean, you know, you're taking one measurement one day, and then 6 months later you're taking another measurement. Yeah, and the differences are absolutely tiny. To actually say this is solid science is really pushing the boat out. Even astronomers themselves, even scientists themselves say, so Robert Woodhouse, the whole range of astronomy does not contain one proof of its own accuracy. Fred Hoyle the same, Astronomer Royal. Can't say that Copernican theory is right and the Ptolemaic theory is wrong. So science isn't settled either. There's a lot of quotes from UFO experts who also say, even Arthur C. Clarke, one theory which can no longer be taken very seriously is that UFOs are interstellar spaceships. And nobody denies that UFOs exist. And we've seen them. You've seen them with your own eyes, seen thousands of videos, we know abductions are real. Implants are real, these things are really happening. But I don't think they're from outer space. You can test it for yourself, but many, many researchers themselves say they don't think from outer space. I'm going to leave it there because it's 3 o'clock. I could easily do this talk for 4 or 5 hours. Either I've encouraged you or motivated you to go and research some of this stuff for yourself, or you just think I'm a complete nutter, so we're back at the start again. Thank you very much for listening, have a great conference.